Welcome back, Wolfpack, to lesson 4.11, Kites and Trapezoids. Our essential question is, how can you determine the similarities and differences between various quadrilaterals? We're going to talk today about two shapes that you may be a little less familiar with, and that is kites and trapezoids. Kites, you've probably seen a kite flying in the wind, but it's actually a mouth shape. And then trapezoid, I'm certain you've probably heard of that shape before. But kites and trapezoids are quadrilaterals that are not parallelograms. So they do have four sides, but the opposite sides of those shapes are not parallel. So they are not parallelograms. A kite is a specific type of quadrilateral, and we will go over the properties of that one first. Sorry about the interruption. We'll go over those properties first. A kite is a quadrilateral with two distinct pairs of congruent consecutive sides. So for example, CB is congruent to AB in this shape, and CD is congruent to AD in this first kite. A kite does not have any parallel sides. None of them are parallel. Their diagonals are perpendicular, which means they form at 90-degree angle or they intersect. One diagonal bisects the other. So they're not both being bisected, but one of them is bisecting the other. So the long one is bisecting the shorter one, cutting it into two equal pieces. One of the diagonal bisects the pair of non-congruent angles. So for example, you can see that angle C is congruent to angle A. So this diagonal, BD, is bisecting angle B and bisecting angle D. Okay? The diagonal that is going from C to A, it is not bisecting the angles. It's cutting it, but not cutting it in half. So the diagonal that bisects the angle, it's the non-congruent angle. Two pairs of consecutive sides are congruent, and one pair of opposite angles are congruent. That's a lot of properties of kites. Kites are probably the most difficult shape to remember the properties of, but I'll try to make sure we have lots of practice with them. A trapezoid. It's a quadrilateral with only one pair of parallel lines. So it's not a parallelogram, because it does not have two pairs, it has one pair. The sides that are parallel to each other are called the bases of the trapezoid. And the other two sides are called the legs of the trapezoid. And then there can be a special type of a trapezoid called an isosceles trapezoid. An isosceles trapezoid also just still has one pair of parallel sides, but its legs are congruent. You can see BA is congruent to CD. And each pair of base angles are congruent. So angle B is congruent to angle C, and angle A is congruent to angle D, and that's just in an isosceles trapezoid. Also, the diagonals in an isosceles trapezoid are congruent. BD would be equal to CA. Okay, these are all extra properties for isosceles trapezoids. One thing to keep in mind, that because a trapezoid has parallel lines, so this base is parallel to this base. When we have a transversal, the same side interior angles add up to 180 degrees. Okay, we'll need that property to solve some problems. Let's look at example 1. Find the measure of angle 1 and the measure of angle 2. So example 1A, this is a trapezoid. I see four sides, one pair of parallel lines. So because it's a trapezoid, here are my parallel lines. This angle and this angle have to add up to 180 degrees. So angle 1 is equal to 180 minus this angle. Well, that angle is 90. So angle 1 is also 90 degrees. We'll find angle 2 the same way, because angle 2 and angle 53 degrees have to add up to 180. So angle 2 equals 180 minus 53. Angle 2 is 127 degrees. Okay? Because they have to add up to 180 degrees. So letter B, that is not a trapezoid, that's indeed a kite. And you can see that this diagonal cut the kite into two congruent triangles. I know they're congruent because I have a side congruent to a side congruent to a side, and then they share a side. So these two triangles are congruent by side, side, side. And if you remember, that means their individual pieces are now congruent to each other also. That means this angle is congruent to that angle because corresponding parts of congruent triangles are congruent. So that means angle 1 is also 110 degrees. Now, because these two triangles are congruent, I'm going to erase so we can see a little bit better. This diagonal is bisecting those two angles. Well, this angle is 90 degrees. That means this one is 45, and this one is 45. Well, if this entire triangle adds up to 180 degrees, angle 2 is equal to 180 minus 110 minus 45. So 180 minus 110 is 70, minus 45 would be 25 degrees. Angle 2 would be 25 degrees. Example number 2, find the value of x. Notice how a kite can be cut into two triangles, and those triangles are congruent by side, 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 which is what I just mentioned. This side is congruent to this side. This side is congruent to this side. And then they share a side. So these are two congruent triangles. Now, all of the angles in a triangle have to add up to 180 degrees. So I can take 2x, which is this angle, plus x minus 6, plus 3x. Set it up as 180 degrees, and I can solve for x. 2x plus x is 3x, plus 3 more x is 6x, minus 6 equals 180. And then 6x equals 186. Divide both sides by 6, x equals 31. So x is equal to 31. I also could have solved it a little bit easier. Because I know these two triangles are congruent to each other, that means this angle is congruent to that angle. So x minus 6 is equal to 25. Add 6 to both sides, x equals 31 degrees. Or judges that x equals 31, not necessarily 31 degrees. Okay, so two problems we could have solved that. Problem, I showed you the long way first, and then I showed you the shorter way. But you'd have to know that these two angles are congruent in order to be able to solve it the shorter way. Okay. We will do example 3 and 4 together in class. Let's move on to the trapezoid midsegment theorem. The trapezoid midsegment theorem says that the midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So they're in the middle of the legs. It is parallel to each base, and its length is 1/2 of the sum of the lengths of the bases. So kind of like the midsegment of the triangle. This midsegment, M, cuts AB in half, and the N is cutting BC in half. So it's making two equal pieces on each side. It's parallel to the top and the bottom, and it's half the sum of AB plus DC. So let's do an example. Example 5A. We're going to find the midsegment. So the midsegment is MN. MN is equal to PQ plus SR divided by 2. MN is equal to PQ, which is 16, plus SR, which is 9, divided by 2. MN is equal to 25 over 2, or you could make it 12.5 if you were working this out on a calculator. Right? So it's equal to the sum of 16 plus 9 divided by 2. and we will do example 5B in class together. If you have any questions, as always, please write them on your notes. And we are almost done with this module. Have a great day, Wolfpack, and I will see you next class.